Let's try to solve another Leetcode problem 647, palindromic substrings. So for this problem, we are giving a string S, and we are going to check how many palindromic substrings. So for example, ABC, so we have the palindromic substrings with ABC, so it's going to be 3. And for this AAA, it's going to be 6 different cases, like this AAA, and we have 2 AA and another AAA. So in total, it's going to be 6. Actually, this problem is similar to Leetcode problem 5. So for the Leetcode problem 5, it is the longest palindromic substring. So this is for checking which one is the longest. We're going to return this substring. And for Leetcode problem 647, we just need to count how many palindromic substrings. We are not only going to calculate the longest, but we are going to count how many in total. Yeah. So we're going to use 2 methods to solve it. So the first idea is the center spreading. So we're going to call it a center spreading. So we're going to spread it. So for example, this is a ABC. So we're going to check A going to be the center, and we're going to spread it from the left and to the right side to check how many of them. So for one spreading, it's going to be O(n) time, and how many characters, it's going to be n characters. So the time complexity is going to be n squared. Yeah. So another case is that we're going to have the center of AA, and this is B and B. We're going to spread it from here, from 2 indices at the same time. So we're going to check how many of them. So this AA, we're going to count it as 1, and then we're going to spread it. This is BB, we're going to count it as 2. So for example, if this is C and this is D, we're going to stop the counting. Yeah. So the second method is dynamic programming. So the idea is that this is the string S. So if we are going to calculate, so for example, this is character maybe A, and this is B and B, and BAB going to be a substring. So if this substring is a palindrome, now what we are going to check is from the left and the right side. For example, this is C and this is C. So if this character C equal to this character C, it means we just need to check the subproblem. Yeah. If the subproblem is palindrome, normally, definitely, the whole string going to be a palindrome. We just need to return the longest string. So this is the dynamic programming idea. But if this is C, this is D, if they are not equal, so we're gonna ignore it. We will not check it. We're gonna return the substring, which is gonna be BAB. Yeah. Now let's just use the first idea on center spreading. So I'm gonna prepare and maybe a count or result. Let's just use a result. So n going to be length of the string, and the result going to be 0. Now I'm going to prepare a helper function. So it's going to be 2 indices, I and j. So the condition is that while I more than or equal to 0 and j less than n, and si equal to sj, we're gonna spread it from the center. So I gonna minus equal to 1, and j gonna plus equal to 1. Finally, we're gonna return the count. So here we're gonna use the result as a count. It's gonna be 0 from the beginning. So if this is valid, we're gonna update the count. So the result is gonna plus 1. And finally, we're gonna return the result. So this is the helper function. It just helps us to count if B is the center, how many of them in total. So this is just for the helper function. Now let's just start the main function. So for I in range n. So currently our counter is this result. Yeah, here. So result gonna plus equal to the helper function. It's gonna be I, and another helper function. It's gonna be I and I plus 1, because definitely there are gonna be 2 cases. Finally, we're gonna return the result. So this is gonna be the count, how many in total. Now let me just run it to check if it works. Now as you can see it works. Now let me just submit it. As you can see it works, and it's pretty fast, and the time complexity is O(n) squared. For the helper function, this is O(n), and how many helper functions, it is another n. So the time complexity is O(n) squared. n is 10 to 1000, so this is okay. Now we're going to use another idea, which is going to be the dynamic programming. So it is actually similar. So we're going to prepare two variables, n and result. So this result is just a counter. Now we're going to define our function. So as we are going to count how many of them, actually we're going to set a false times n for anything in range n. So this is just a state function. We just need to check if this substring is a valid palindrome or not. So from the beginning, we're gonna set all of the substrings are gonna be will be invalid. So we're gonna set a false. And now if it is a valid, we're gonna set it to true. So how can we check that? So for example, we have a string of ABC. We are going to check if we are going to check AC. So this substring B must be solved already. Yeah. So so this is a similar like brute force. Definitely we're gonna check all the different cases. Yeah. So we're gonna set two pointers. So one pointer is J, another pointer is I gonna always be less than and equal to J. And for this kind of two for loops, we're gonna check all the cases, and we're gonna count it. Yeah. So we're gonna use our pointer J for J in range n. And what about I? Just for I in range J plus 1. Because only in this way, actually we are checking all the different cases. While we are checking all the different cases, we're gonna always calculate the substring first. And then we're gonna check this side and left side and the right side. While we are checking this left and right, actually the substring has already been solved. Yeah. So this is why we're gonna use two for loops like this. So for J in range n and for I in range J plus 1. In those two for loops, actually we are always solving the subproblem first before we are solving the whole problem. Yeah. So the condition is that if Si equal to Sj, if they are equal, so what about the subproblem? So J minus I less than or equal to 2. So this is one of the valid case. So another is Fi plus 1. So this is going to be the subproblem, and J minus 1. So we're going to set Fij to true. And we're going to update the counter. Result is going to plus equal to 1. And now we just need to return the result. Now let me just explain on this line of code, because this is very important. Yeah. So the first case is what about if they are equal? So for example, if this is A and this is A, maybe in the middle there is a B. So this is J and this is I, and J minus I more than or equal to 2. It means the length of this substring gonna be at least 3. If it is 1, it is okay. If it is 2, if it is 1, it's like a B. If it is 2, it's something like AA. So it's gonna always be valid. If it is 3, BA, it's gonna always be valid. So this is one of the cases. So another case is that this is a substring and this is valid. So what about here is A, here is A. Maybe this is more than the length is gonna be more than 3. It's gonna be something like maybe AB and BA. So if this A equal to this A and the substring is valid, so this means our string gonna be valid. So this is the second case. Yeah, this is the substring and this is our string. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. As you can see, it passed for all testing cases and it's pretty fast, and the time and space complexity are both O(n). Are both O(n) square. I think that's all about it. Thanks for watching. See you next time.